Okay, so this is the second part of the editorial video of dynamic range sum queries, where we were implementing the segment tree. And please watch the first part if you want to understand this more clearly. We'll just be coding the segment tree out in this video. So to code out the segment tree, we need a total of three functions. And first will be build function, then update function, then query function. But I will be using the update function to build the array, so we won't need the build function. Let's take update. So before I do that, let's just declare the segment tree and the array to take input from. So I've taken the segment tree of size 4 star n, and you can Google this, why we take 4 star n size in segment trees, or maybe I'll explain it to you in the end at the end of the video. Now let's take n and q globally just so we can use it in the update and query functions. Now take the input for n and q, and then also the input for a, right? And then let's say we have our update function ready, right? Let's say we have the update function ready. Then it will have two variables. One will be the index where we need to update. I'll just write it as id, and one will be the value that will be updated, right? Now to update this, I'll just write update. To build the array, I'll just write update at ith position the value of ai. So build the array, sorry, segment tree. Now let's see. So now let's implement the update function before we go forward, right? So to as I explained in the first video, to write a update function, we need to keep three parameters. One will be the index of segment tree where we are currently at, the node where we currently at. So let's just call it node, and then left pointer, and then right pointer, and these will be defaultly parameterized. They will have a default value of 0 to n minus 1, and the node will be this. Okay, so now if the left and right the if the index does not lie between the range left and right, if the index does not lie between the range left and right, we will just return. We don't need to update anything else. So if id is greater than right, or id is less than left, we just return. Okay, so if l equals left equal right, if left and right are equal, and l equal id, left equal id, so we'll just write the value segment of I equals to value and return. Okay, so we stored the value well at the node of this segment tree. Okay, now let's create a mid variable and update the values from update the value for left child and right child. Okay, let's see. So we provide the values we want to update. And to access the left child, the formula that I showed you in the first video will be node star 2 plus 1. So we'll write the same formula here, node star 2 plus 1 and left comma mid. And here we'll write node star 2 plus 2 comma mid plus 1 comma right. Okay. Okay, so that's how we update left and right. And after updating left and right, we just set segment of I is equals to segment of I start segment of node equals segment of node start 2 plus 1 plus segment of node start 2 plus 2. Okay, so this is how we write the update part. Now let's write the query part. Let's take the type of the query as input. Now if the type equals 1, then we take ID and value, and to compensate for zero based indexing, we just subtract ID by 1 and write update ID comma value. That's all we need to do. And otherwise we query, we take input for query left and query right, and then we output the answer for query of QL comma QR. This will be the main function that we'll use. We don't need to write any more code for this. Now let's implement the query function. QL, and QL is just the query left and QR is just the query right, and we take these three parameters as our default parameters again, just so we can traverse the segment tree. Now let's do this. Let's implement this. And if left and right completely lies between the range QL and QR, so if left and right are completely in the range, let's say QL comma QR is equals to 0 to 7 and left and right are 0 to 3, then this completely lies between this, right? So we just write if L greater than equal to left greater than equal to QL and right less than equal to QR, return the total segment, right? Segment of node, answer for this segment. If none of the elements lie between the range, if left and right are completely out of the range this, so let's say QL and QR are 0 to 3 and left and right are 4 to 5, then we return 0, right? Okay, so we've done this. Now let's take mid element L plus R divided by 2 and just save segment tree of I, or just return query of QL and QR. These are the query output inputs, and then we change the node to the child node, left node. Now notice this, for the query which are completely inside, we have returned the answer. For the complete query where the answer is completely outside, We've returned the answer. This part that's left is the partial part. So the answer will come partially from mid, from L to mid, and from R mid to R plus 1, mid to R. So there will be two query of function calls. One will be I star 2 plus 1, comma L, comma mid, and other will be query of QL, QR, I star 2 plus 2, mid plus 1, comma R. I have a very bad habit of writing Q left and right as L and R. Right. So this should be fine. This should work. Let's try to run it. The answer turns out to be wrong. So why is this wrong? Oh, we haven't compensated for QN and QR. We have to compensate for zero-based indexing, right? Let's run the answer again. And the answer is right. So yeah, that's how you build a segment tree. I hope you were able to understand this. Thank you for watching.